So this is our EC3130 final project. It's a little robot we built and programmed to navigate around different obstacles. The basic idea is that we have an ultrasonic sensor here on the front of the robot, and we have two servos that control the yaw and the pitch of that sensor. And so as it drives around, the two servos sweep left and right, and it detects obstacles. And when it finds an obstacle, it sweeps up to detect the height of the obstacle. And if it can't go over the obstacle, it'll turn to avoid the obstacle.
So it's driven using two DC 12-volt brush motors, just basic brush motors. To control them, we used two dual H-bridge motor controllers, which basically sending it a certain combination of bits tells it whether to run the motors forward or backwards. And using two of them means that we can turn one motor forward and one motor backwards, both motors forward, motors backwards, to get it to move forward, move backward, turn, so on and so forth. The servos are controlled using PWM, pulse width modulation. The Dragon board actually has 4 servo ports built in. The one pin, these triple pins right here, one pin's ground, another pin's power, and the third pin is connected to one of the ports, which you can put a pulse width modulation on. And depending on what the width of the pulse is in a certain amount of time, I think it's like between 1 and 2 milliseconds per 50 millisecond cycle, tells the servo which angle to turn to. Got anything else? For the ultrasonic sensor, it uses a what's the name of it?
Interrupt capture?
Interrupt capture, yeah.
Right.
Or input capture, interrupt.
Capture, right.
Timer interrupt. So the way it works is that it has the ultrasonic sensor has 4 pins: a ground pin, a VCC pin, and a trigger and echo pin. So the way it works is that we use port A7 to send a 10 millisecond pulse, 10 microsecond pulse to the trigger pin. That causes the one for it to send out an ultrasonic signal, and also it sets the echo pin to high, which then triggers the echo pin is connected to the interrupt, and so that basically starts the timer on the interrupt. Once the ultrasonic pulse hits an object and comes back to it, it drops the echo pin back to low, and so using the input capture interrupt, we're able to measure the pulse width, and the time of that pulse width is use a little bit of handy-dandy calculations to find the distance from the ultrasonic sensor to the object that it senses.
And so in the demonstration video, you'll see that the servos move to a new position about every 50 or 60 milliseconds. And so every time it moves to a new position, it's going to send out a new pulse and detect a distance from that pulse length.
The ultrasonic sensor is actually faster than the servos are. So we had to put a delay after every time it gets a reading. We had to put a delay on it so to let the servo move to the next position before it read again, because the ultrasonic sensor is working on the order of microseconds. Microseconds.
How's it powered?
It's powered ridiculously using 3 battery packs. We have a 12-volt battery pack using 8 AA batteries, and that powers the 12-volt motors. We have a 6-volt battery pack with 4 AAAs to power the servos, and which are 4 to 7-volt servos. And we have a 9-volt battery to power the Dragon board, because on the Dragon board it had not only can you plug it in here or use the USB, but it also has just these two 2 power pins right here, which if you plug it in, will power the board.